So hi and hello there, welcome to the new video of the course, and in this video we are going to see the type and symbol of JFET. Okay, but before coming to this part we will just focus on the types of transistor, and this particular topic, if you could remember, we had studied in the lecture 5 in course number 4, that is analog electronics part 2, where we were dealing with BJTs. Okay, so the transistors were divided into two types, that is BJTs and FETs, and FETs were further divided into JFETs and MOSFET. Okay, and we had seen the BJTs were also divided into two types, that is NPN and PNP transistors, and generally we prefer to use NPN, okay, rather than using PNP. So in most of the application you will find NPN. Okay, but due to due to advancement in transistor, or due to introduction of FETs, okay, people prefer to use FETs, and in FETs as well people prefer to, I mean, the in most of the application people prefer to use MOSFETs over JFET. Okay, but still, in market, still JFET is in used in certain applications. Okay, so that's the reason why we are focusing on JFET. Okay, so now what we'll do, we will focus on the types of JFET, type of JFET. Okay, so let me write over here type of JFET. So let me write over here as JFET, uh, JFET, that is junction field effect transistor. Okay, this is further divided into two types, this is type 1 and this is type 2. So the first type is, just a second, so the first type is N-channel JFET, N-channel JFET. Okay, N-channel JFET. And the second type is P-channel JFET, P-channel JFET. Okay, so these are the two types of JFET, that is N-channel JFET and P-channel JFET. I'm just giving you a short in idea, okay, or this short introduction, that what exactly happens in N-channel JFET and P-channel JFET. So in N-channel the majority charge carriers are electrons, and in P-channel the majority charge carriers are hole. Okay, so we are going to see this particular thing in depth when we will be dealing with the construction and the internal structure of JFET. Okay, so we will be dealing with this particular part in depth. Okay, so as of now we'll just write it over here, write this particular 2 points over here. Majority charge carriers are electrons in case of N-channel JFET. Majority charge carriers are electrons, and over here majority charge carriers are hole. So basically, whenever I say that majority charge carrier, so that means what? The current flows because of electrons in case of N-channel JFET, and in case of P-channel JFET the current flows because of holes. So this is the basic idea behind the N-channel JFET and the P-channel JFET, although we will just brief this idea, okay, whenever when we will focus on the internal structure and the working of JFET and all. Okay, so let me proceed further. So this is the symbol of N-channel JFET, okay, and P-channel JFET. I mean, if you could see very clearly, there are three terminals, that is D, G and S. So let me write over here what exactly these three terminals signifies. So this D, it represents drain, D means drain, okay, D means drain. G means gate, and S means source, So as you can see, there are three different terminals of JFET, that is DGS, that is drain, gate and source. Okay, in the N-channel JFET as well, and in the P-channel JFET as well. Now if anyone asks you that what exactly is a transistor, or the basic function of transistor, so now that we had a good idea about the transistor, especially about the BJT, so what we were doing in case of BJTs, if you could remember, let me just draw the symbol of BJT. So this was the symbol of BJTs, right? So what we were doing in case of BJTs, we were providing certain input current, okay, that is IB to the input side, and at the output side we were getting some magnified form of the input current. So this input current was roughly in microampere, and this output current was in milliampere. So as you can see, what we were doing with the help of transistor, the input signal or the weak signal which we were providing to the input side, it was getting magnified at the output side. So this was the basic idea of transistor. On the similar note, we are going to see the JFET as well. So basically over here, instead of current, we are going to provide small voltage. Okay, so basically, long story short, in case of JFET, in case of BJT, we were providing the small current, but in case of JFET, we would be providing one small voltage, which will actually provide the magnified form of the input signal, and our input signal is a voltage. So at the output side, we will get a magnified form of the voltage. And when I say that we would get, or we should get, the magnified form of the voltage at the output side, that means what? We will be also getting the magnified form of the current. Okay, so that we will focus on the upcoming session, that you need not worry over here. But the point to notice over here is that, see, try to compare BJT and JFET, and then when you try to compare, then what you can see over here is that this is your collector side, this is your base, and this is your emitter. So what we can clearly see over here is that, treat this drain, or assume this drain as what? Assume this drain as the collector of the BJT. Okay, although we are dealing with JFET, but try to compare these two, because that will really help you to understand this particular JFET in very in detailed way. Okay, then try to assume this gate as your base. Okay, and try to assume this source as your emitter. Okay, emitter. That we will see that how exactly recurrent flows because of these three terminals. In case of BJT, what we were doing, we were applying certain voltage, okay, VBE, okay, and then we were getting certain current. Okay, that means we were actually providing the current IB, or the base current, to the input of BJT, and thus we were able to obtain the output current, or the magnified form of the input current. Okay, and in case of JFET, what we are going to do over here is that the similar thing which we were doing in case of BJT, the same thing we are going to do over here. That means we are going to apply certain voltage over here, and then we are going to get certain output voltage based on the input voltage. That would be the magnified form of the input voltage. Okay, so this is the basic idea of the JFET. Okay, and now the important thing to notice over here is that, see, as a student, me being a student at that time, when our instructor taught us this particular thing that is about JFET, that means the symbol of JFET, at first what I thought was that, see, when you see this arrow, okay, when you see this arrow, the very first thing hits in your mind, if you are very much well aware of BJT, is that this arrow signifies this. Okay, that means what? You assume that the current will move towards JFET in case of N-channel JFET, and in case of P-channel JFET, you assume that the current is moving away from the JFET. But believe me, this is absolutely wrong. This is absolutely wrong. Now you will ask me, sir, why? Because in case of BJT, when this arrow was pointing out, in case of NPN, I'm talking, in case of NPN BJT transistor, bipolar junction transistor, when this arrow was pointing out, you said that the current was moving away from the base terminal, or rather it was moving towards the emitter, right? So basically the current was moving in this particular direction. But now since we are dealing with JFET, this arrow is pointing in. So now you are telling that this arrow does not resembles the current. Is there any reason for it? Yes, of course there is one reason for it, because now we are dealing with JFET, junction field effect transistor. Okay, so the full form of JFET is junction field effect transistor. I will elaborate the full form in the upcoming sessions. Okay, so remember one thing, this arrow reflects the current, okay, in case of BJT, but in case of JFET, it does not reflect current. That means the current won't be flowing in this particular direction in case of JFET. Okay, N-channel JFET, and the current won't be neither be flowing in this particular direction as well in case of P-channel JFET. So this arrow specifies, or it signifies certain different thing. Okay, it is not similar to the BJT. It does not represent current. Let me write over here, because generally students assume that this arrow represents the current. No, it's not like that. So over here, let me just draw this arrow, and let me extend it somewhere over here. So arrow does not pacifies the direction of the current. Arrow does not indicates the direction of the current. Let me write this particular point, because whenever you will refer the PDF, you should be able to know this particular thing, current. Okay, rather it resembles certain different thing, which we are going to see in the next video, that is in the construction part. Okay, or the internal structure of JFET. Okay, so I hope you understood this particular whatever concept that we had deal in this video. As such, we don't deal with any of the concept in depth. What we did, we just understood the types and symbol of JFET. So at first we saw the types of transistor, that is FETs and BJTs. In FETs we are dealing with two types, that is JFETs and MOSFETs. Okay, in case of JFET is further divided into two types, that is N-channel JFET and P-channel JFET. The majority charge carriers are electrons in case of N-channel JFET, and the majority charge carriers are holes in case of P-channel JFET. I told you that we will elaborate on this particular point in the upcoming session, so you need not to worry about it. It's just a kind of difference between N-channel and P-channel difference. P-channel JFET. Okay, it's like a difference. Okay, and the third thing that we saw over here was the symbol of JFET, and I told you what, there were three terminals of JFET, that is drain, gate and source. I will elaborate in the upcoming session that why we call this terminal as drain, why we call this terminal as gate, and why we call this terminal as source. Okay, we will see this particular point in the construction or maybe in the working of JFET, so you not to worry about this particular point. Okay, you just remember that there are three terminals of JFET, that is drain, gate and source. And when you try to compare this particular JFET with the BJT, so you come to know that this drain will act as the collector, this gate will act as the base, and this source will act as the emitter. Okay, so try to think in this way. Okay, and then what I told you is that in case of BJT we were applying the small input voltage to the base emitter junction. On the similar note, in case of JFET we should apply the small input voltage, okay, or the small input current. Okay, in case of BJT we were applying small input current, any which ways for providing current we need to apply voltage, right? So on the similar note we need to apply small input signal, okay, to the gate source terminal of the JFET, and at the output side, that means at the drain source terminal you would be getting the magnified form of the input signal. Okay, so now by now you might have got a clear cut idea that we are going to take the input from the gate source and we are going to get the output from the drain source. And that's why I told you, now if you are learning from me, I will teach you each and every point in great depth. Now you have got a clear cut idea about BJT, so now you can easily relate it with the JFET. Okay, and in case of BJT, what I told you, in case of BJT, that means in course 4th was this arrow specifies or it indicates that the current is moving in this particular direction, right? But in case of JFET, this arrow does not reflect the direction of the current. Okay, rather it reflects certain different things. So that's why I had intentionally pointed out over here is that arrow does not indicate the direction of current, rather it represents certain different thing which we are going to see in the upcoming session. Okay, so I hope you understood whatever things that we had discussed in this particular video. But still, if you face any doubt, if you have any difficulties, feel free to ask me at any time. Okay, I will surely help you out here. So thank you for listening patiently. I'm ending this video over here. Thank you.